Welcome back, everybody. Today, we are going to revise most of the topics we have covered so far. The most important, not everything, but the most important. So let's first create a folder, week 6, I don't know, but it doesn't matter anyway. Then I will create a Python file and I call it revision.py. I think this revision will help you to master the fundamentals. Yeah. So let's say what is fundamental of programming. Yeah. So in any programming, I think the fundamental is actually the variables. Yeah, we have to know the variables, how to declare variables, and also how to create a very good variable names. Do you remember mnemonic variable names? For instance, when we say first name, it's so clear that we're about to declare someone's first name. It could be, for instance, my name. Yeah, and if we say last name, and I can say my, and if I say country, yeah, the country I come from or the country I live, it doesn't tell what country, but it doesn't matter. At least it shows something still. Let's see, Finland. And so as you can see, it's very mnemonic. So anyone who reads the English language can understand this, right? And the equal sign doesn't show equivalence or equality. Instead, we are asking this first name variable to store this as in a data. And we are storing this in here in a memory location. We are storing this here. Yeah, great. So we call this variable names. How do we write variable name? As you can see, first name, we call this camel case, as you can see. There's underscore. This is also still a valid variable name, but a variable name doesn't, it's not allowed to start with number, for instance, like this. It's not, but we can have a number like this, for instance, first name 1 or whatsoever, okay? And we can't use a symbol. We can only use underscore, but we can't use any symbol, sorry. Yeah, that's the rule for variable names. So for instance, year, this is valid. Year, this is a valid variable name. Or maybe current year. This is still a valid variable name. Yeah. This is also valid, but this will not be valid. It's not valid. This is not valid because it starts with number. So this is the minor difference you have to consider whenever you declare a variable. And then what it comes actually this hash, we should know how to comment. Comment in a programming language. This is a single line comment. A single line comment. Why we need comment in our code? Okay, we have different reason. One is to make our code readable by ourselves or someone else. Yeah, because after you leave your code for some time, it might be hard to read. Also, maybe your colleagues, or if you are a blogger or something, people around the world are reading your code and they should have a way to understand what you are trying to say. Yeah, so it allows us to leave some remarks to make the code more readable. Yeah, great. Then what we should really know is actually data types. Oh yeah, data types. Data types. So data types, everything we store, everything we return from a function, anything we work with is actually data types. And in Python, we have different kind of data types. Let's start from numbers. Numbers could be int or float or complex number. Yeah, that's the numbers data type in Python we have. For instance, let's say a number, I can say age. Yeah, I can say 250. That's my age anyway. And then maybe height. The height should be in floats, right? So I can go for float. Maybe I think I am about 1.73 centimeter. Yes, very short. That's okay. A complex number. Yeah, let's just complex number. Sometimes you may need it in electricity, in some circuit calculation, or in some mathematical calculation anyway. Yeah. So let's store complex number num, usually 1 plus j. This is a complex number, right? So, but do we need it most of the time? No, we don't need it. Ooh, for why is it? Let me check. Print type, and the type method now, complex number, allow us to know name j. Why? Really? How? Oh, okay. Let me check the structure of complex number. I may forget it. Complex. Yeah, with some, okay, is it I? 1 plus I. Okay, let's try. So maybe I should have already. Let's check in here, data types and numbers. Strings, okay. One plus one j, okay, that's good. But this should be then a variable. Yeah, okay. Let me just j. Yeah, so we have to indicate that really, so it doesn't just take the coefficient by itself. So it should be 1 or 2 or something. So this is actually a complex number, and if you check it also it says complex number. So we are done with the number types. This is a float, and this is an integer, and this is a complex number, right? And I think by now you're very familiar. Another famous gravity, the gravity we've been using, 9.81. What is the type? And it should be float. And the pi, 3.14. And it's a float, yeah? This is number data type. That's int, float, and complex. If you have seen here type, I have used the type built-in function to check the data type. So another very important thing is function. And then function, what kind of function do we have? Actually, built-in function and a custom function. And now and then we will have we will see this built-in function because it's already there. It's built for us. We don't have to think about it. We just make use of the functions. Yeah. So function allow us to execute some task. For instance, this the type allow us to tell us what kind of data type it is, and the print function by itself is also a function that allow us to print something. Okay, let's move on to again the number, the strings. But before that, actually, we can do arithmetic operation. If we have numbers, arithmetic operation is possible. What's arithmetic operation? The plus and the subtraction, the multiplication, division. We even can go for modulus, that means remainder, for division, and exponentiation, right? By now you have to be familiar with this. Now, for instance, if I am interested to know the area of a circle, I can say area is equal to pi. So the pi is here. I can just say 3.14 times radius. Let's imagine the radius is 10 times 10. I think that's pi times radius square. So this is the area of a circle. Of course, we can make it a bit different. We can also write it differently. I can say 3.14 and then times 10 like this. So this means 10 to the power of 2, right? And even we can write it differently because we have pi here already. Then maybe another or better way also to write it, pi, and maybe it's better also to have the radius separately, 10, and then I can say radius, and this is the square, the area of a circle. How about if we are interested to find the weight of a person, an object? Weight is equal to mass times gravity. Yeah, it's just a physical, it's just a formula. So the mass, for instance, the mass of the body, let's say mass of a person is 75 kilogram. And then actually we can say the weight is going to be, yeah, it's already calculated here. Print weight. Yeah, the mass comes from here, 75, and the gravity comes from 9.81, and there might be some number over here. As you can see, this is in Newton. So now we are doing mathematical arithmetic, arithmetics, but the arithmetics anyway, you may have like A is equal to 3 and B is equal to 4. So print A plus B, and as you can see, this is addition, and print A minus B, and print A multiplied by B, print A divided by B. So we call this operands. Yeah, 2 operands, A and B, and then print A floor division B, print modulus. Let's make from 4. I think it's better. 4 modulus. No, B modulus A. And then I think the last would be B the power of A. So I think you are expecting from here 7. You are expecting from this -1. I'm expecting from this 12. I'm expecting from this 0.75. I'm expecting floor division. I think it's going to be 0. because when you divide 3 by 4, it will not be divisible, so it will be 0, yeah? Then b, that means 4 divided by 3, I think the remainder is going to be 1, yeah? And b the power of a, that means 4 the power of 3, it's going to be 64, 4 times 4 times 4, right? So let's see. Yeah, as you can see, 7 minus 1, 12, 0.5, yeah, 0, the floor division 1, 1 is, so when is that? That's the modulus, and 64. And sometimes when you do something like this, you don't see where it's coming from, so you may say the sum is something like that. So this is like act as a label, you know, so it will be easy for you. The difference will be the difference and the product, something like that. Product of and b, whatever, and the division and the floor division and the floor division and the remainder and the exponential. Yeah, it was long, but we made it right. Let's see. Yeah, as you can see now, you can't miss it because just it's labeled properly. Yeah, this one matched to this. Great. Okay, but now even you can use the string interpolation. Do you remember the string interpolation? At the same time, now let's learn string interpolation. That means if I want to say, to print, for instance, 3 plus 4 is equal to 7, I want to print something like this, yeah? If you want, of course, instead I can say this. Maybe if you say print the sum of, and then you can say plus stir a plus and plus, and again the sum of 3 and 4 stir and b plus is, then we have to have c, a plus b, that means 7 is, we have to have, and then we can have again here stir c. Let me show you this. It's not a very productive way of concatenating. The sum of 3 and 4 is 7, as you can see, but this is really not good. Okay, let me show you a better way. Print, and then you can say f, and then the sum of, and then you can say just like this is the sum of this and this is. Okay. Now, as you can see, I can just inject the value here, a, and then here, b, and then here even I can do calculation, a plus b. Why not? Of course, for readability purpose, you can make it. And now let's see. Have you seen the sum of 7 with the sum? I think I didn't print yet. Yeah, the sum of 3 and 4 is 7. Yeah, as you can see. Now let's apply for all of them the sum. Now here the difference of a and b is just a minus b. So straightforward, right? Yeah, so you can even change all of them. The product of A and B, let's just make this A and B. Here's A times B over, and we don't have to have this. Yeah. The division of A and B is here. We have to put it in a curly bracket, right? Yes. So, but as you can see, I forgot to add the F. You have to have the F to do this string interpolation, right? So the floor division of A and B is, and then A floor. Yeah. Then you don't have to have this. And you can just take this out. And then the remainder of A divided, I think it was B, right? B divided by A. But I should change this to dynamic. What's the importance of this, by the way, guys? If you change the value in here, it will be changed also in here. The power of, I think it would be the power of, the power of, be the power of, I think, be the power of A is, then we can say, great, we don't need this. Now this will be like a mission, okay? What the reason why, as you can see, we forgot to apply this, the F, and we did see it. Yeah, now if you change, for instance, this to whatever, for instance, 4, and I want this 9, and I want this to be 5, and even I don't need this, and this is also very lazy way of writing. And let's see. Yeah, so it just work. Yeah, so this is the arithmetic operation. We are done with the arithmetic operation. At the same time, we saw string concatenation. This is actually one of the string concatenation, the best one and the most used. I love this, but there's also other. For instance, you can do string in another. For instance, you may say print. You can say dot format AB. Yeah, so then you may have this A. Let's see this last. Have you seen now? So you have, for instance, if I have also here A plus B, and I can say here plus, and I can say equal to, yeah. Now, as you may say, yeah, let's make it friendly, space in between. Yeah. Yeah, so you can also use this, the format. Oh, is that, so we can actually rearrange the order if we want this to be the, I mean, if we want this to be, I can say this 2, 1, and of course this 3. So now we rearrange actually, I think it starts from 0. So I have to say that this should be a 0. And this should be 1, and this should be 2. Yeah, have you seen? We can rearrange the value. You don't have to. I think another good example, maybe I can say print. If you have something format, and if you have, say, melon. And if you have somewhere water. So now if you see this, so I want to create a word, watermelon. So if I do this, it will be, as you can see, melon water, but so I have to make this one 1, because then this one should be 0. Now I think the order would be watermelon. Yeah, so we can also reorder. Of course, you can write just this as in first water and then melon, and you don't have to worry about the reordering, and you just leave it like this. Great. But I think since we have learned the different kind of string interpolation before, and also you can refer it from 30 days of Python, okay? We don't have to exhaustively spend the time on string interpolation. Yeah, great. And other things, I think, since I was talking about this, the built-in function, remember, there are quite lots of built-in function. We have used already the print, yeah? The print actually takes unlimited number of arguments. Yes, hello, yeah? World 2021, whatsoever. And we have learned how to also create a function that take unlimited number of parameters. But now, actually, this is the print functions. And then recently we use type. Yeah, type is to know the data type of a function. And then we will see soon length, actually. We see also input to get input data, and round to round, I mean, to get the approximate or the rounding of a number. Yeah, we will use different methods, I mean, functions, built-in functions. In the meantime, let's see string. How do we create a string? Actually, when we declare a variable, actually, we wrote a text, someone's name, and this is a string, and this is a string. To declare a string, it should be in a single or double quote, right? And the length of it could be a letter A, or it could be a sentence. Yeah, I don't know if Lorem Ipsum is working here. Let me try Lorem. Yeah, it could be as long as a sentence, paragraph, or a page. Okay, how long is, yeah, a string. That is. And now, for instance, if I want to know the length of this, okay, len L, it should be 1 because I have only one character, right? Yes, 1. How about the length of this? Print len sentence. Oh yeah, 54. If you remember, we have learned quite a lot of sentence, quite a lot of string methods. For instance, we can change it to upper. So we can change everything to uppercase, print sentence to lowercase, everything to lower. Yeah, as you can see, and the title case, print sentence, and then to title. So title case actually change everything. This every word will be uppercase. I mean, the beginning letter of every word. C uppercase, B uppercase, and let's see. As you can see, every starting letter is, and swap case, print sentence dot swap case. This is crazy. I have never seen any use case for this, but let's see. It could be, that means it's like, if it's lower, it will be upper. If it's upper, it will be lower. As you can see, I was uppercase, Now it's lowercase. T was lowercase, now it's uppercase. That is the swap case actually. Now let's see also print sentence if it starts with something. Is it starting with love, this sentence? Okay, I think for me it's not starting with lab. It starts with the I or it. Yeah, false. How about if I change it to lowercase it? And it's then how about like this? Now it should be true. It gives me a Boolean. Yeah, it starts with how about if I add space? It should be true because up to here it starts with that. Yeah, and we can do the same like this. Ends with. And what's the last? Yeah, does it end with E? Of course, yes. Does it end with the letter page? I mean, the word page? Yes. Yeah, that's how it works. And we can also split this actually into words and print sentence, split. And then if you write, for instance, like this without adding anything, it will be splitted into words. Yeah, it's so nice now, as you can see. But it would be nice cleaning first the all the punctuation. So if you remember, we have learned replace, print sentence dot replace. I have a punctuation for the time being, this one, and then I can replace the comma with nothing. Yeah, and after that I want to split. As you can see, this is a clean, it seems it's not actually. It's not. Why still we captured this? Oh yeah, do you know why, guys? Because even though we remove it, we didn't change this. So after that, let's rename this. Yeah. First, I'm modifying this and then storing the clean version in the same. You can use different variable name, but it's okay. Now, yeah, it's clean. Great. Now we have a list. This is the list, right? Oh, great. Oh, okay. So, yeah, this is some of the basic methods of string, but actually, for instance, let me just write a language. What's the language we are learning? Python. So we can also have access actually each value by index. So if I say print language, and if I say 0, I'm accessing actually Python P, the first letter. Yeah, as you can see, it's P. How about print language and then 1? I'm expecting Y. Yeah. Yeah, great. And print language -1. And as you can see, we can also use the negative indexing, and -1 refers to this one. We can -1, -2, -3. But if we are going through this direction to the left direction, 0, 1, 2. Yeah, I think you are very familiar with that. And we can also use the split and language.split. If we split this, actually it will be changed to list of letters. Oh, yeah, no, it doesn't. It will be a list of letters if we use actually a list, and then you can say language, and now you can change it to list of letters. Great. Sometimes if you are interested to change list of letters, you do something like this. Great. And can we loop through the for, you know, right? Looping. So it's now for loop L in language, can we print L? Let's try. As you can see, I can also print all the, because this string acts like a list, as in a sequence, it's a sequence. Okay, great. If we saw already strings, now let's talk about Booleans. There's no much to talk about Booleans. It's just true or false. Yeah. When do we get a true or false value? When we compare values. Yeah, we compare values. For instance, when we compare, is it 1 less than 0? Of course. So it's going to be true. And if I say if print 1 is no, I think this is false actually. Is 1 greater than 0? True. And if 1 is less than 0, this is really false. Yeah. So when we compare some values, the result is going to be true or false, right? Yeah. So comparison usually leads us to a Boolean value. And what's the importance of these Boolean values? To make decisions. For instance, if all the time true, if true all the time, yeah, well, but there's not, yeah, maybe I think actually happy, true, then we can say if happy is equal to true, do something now, go for coding, right? Open VS Code and write some Python script. No, I'm just kidding, guys. Just doesn't matter if you're happy or not. Just open your VS Code and just write your Python script anyway. So as you can see, happy, yeah, but we don't have to compare this. And if happy, then we do this. Happy. Yeah, open VS Code and write some Python script. Else, print, try to be happy first. Okay, now if you just turn this to false, actually, this block of code will be executed. Yeah, let's try to be happy first, but I think a better way of let's do a is equal to 5. If a is greater than 0, I can say print a is positive, yeah, and else print is negative. Let's see. A, what's the value of a here? 5. 5 is greater than 0. That's true. So it's going to be positive, definitely positive. But how about if this is 0? A is negative. Now it's not. So we need additional condition. If a is equal to 0, then print a is 0. And of course, we have to be sure that also if a is less than 0, print is negative. Else, no one knows. Not a number. So this comparison now, as you can see, this comparison allow us to do some conclusion or decision to make some. A is 0, yeah. How about minus 10? Let's see. A is negative. Now instead of saying A, we can actually use string interpolation, and I can say like this and inject like this, right? I love injecting data. So, because it's very dynamic, whenever you change the value of the data, you also see the result. Like it's not a fixed or static data. As you can see, -10 is a negative number. Oh yeah, so a very good statement is 0 is number. Yeah. Great, lots of people are coming now. So as you can see, so this Boolean is very important. What data type are we going to see? So far we have seen numbers, we have seen Booleans, we have seen strings, and let's talk about, oh yeah, lists. Lists are very, very important data types in Python. Do you love lists? For instance, you can say nums, and you may say 1, 2, 3, 4. And you can see list of numbers. Actually, list got many methods. We can append, we can pop, we can extend, and yeah, it goes. I don't remember everything by heart now. So how do we access it? We can access actually the value of the item in the list, nums. And if I say 0, I am accessing the first value and it should be 1, right? And if I want to access the second, nums, and then it should be with index 1. Let's see. I think this should be clear for you. And also we can use negative indexing, print nums, and -1 refers to this value, right? And let's see, great. And this related to lists, sometimes we can create a very cheap list data. Do you remember the range? The range is really great. And if I put actually 4, it creates a value between 0 and 3, integer value, guys, integer. Okay, so let me show you by printing this. Hey, print this. And then what you see, 0 to 4, but 4 is not inclusive. So if we just change this to a list, and then let me show you. Oh yeah. Oh, 0, 1, 2, 3, 4. Nice. You know, writing by yourself, creating by yourself would be, now, for instance, if I want to create this up to 100, let's see. Oh, yeah. Now it's so beautiful. But actually, this is so beautiful that it's up to you. I think you might have forgotten already how this works. Let me just explain this again. Range creates a range of integers, and it has starting, end, and step. Okay, for instance, if you write range, and if you just write something like this, I think 10 is too long, but let me just stop at 4. This means the starting is going to be 0 and the end is going to be 4, but not inclusive, and the step is going to be 1. Yep, by default. So if you do something like this, so we see the starting by default is 0 and the end is 4. The increment or the step is actually 1. Okay, so now maybe it would be good if we change it to 10 and then 0 by default. And let's see the increment 1. The increment is also by default 1. And let's see, name is not, what's name here? Oh, we don't, let me just remove that. As you can see, yeah, but now let's change the increment to 3 by 3. Then it will be 0, 3, 6, 9. Have you seen? And maybe if I want to start also from 3. So it's up to you to decide. So now you can use also the range to create. Now if I want to create even numbers, evens, I can say range, and maybe I can first list range. So even usually starts from 0, and I want it to end whatever, maybe up to 100, 101, and then it should increment by 2. And if you print this, you will get all the even numbers from 0 to 100. Oh yeah, great. The same goes for odd numbers. So let's do for odd numbers. And let me just change this to odds. And then odd should start from 1, and it should increment by 2 actually. Yeah, so let's just get that. Yes, as you can see, 1, 3, 5, 7, and up to 99. Great. So we use the built-in function range to create lists. And now how about modifying, let's just, wait, don't do that. Let me just take this away and put it here. Now we have this little list, the nums. How about if I want to modify maybe 2 or 1? So this is how you modify nums, and 0 instead of 1, I want to change it to maybe 10 or maybe 100. And let's see, print and nums. By now, you should expect 100 and 2, 3, and 4, right? Yes. Okay, and then you tell me, how can I modify this 4 to maybe 0 or whatsoever? I think I may expect something from you. Just tell me. Yeah, tell me, how do I modify that? Yeah, first I can use 0, 1, 2, 3. And then value, some value, maybe 40 or 400 or maybe whatever number you want, yeah? So you may say modified, even it could be string. So if you run it now, you may see, because we didn't print after that, print nums, and as you can see, we modified it. Oh, great. Then how about removing items? We can use this pop. If we want to remove item from this side, we can use pop. Yeah. So maybe let's just stop this modification. And if I say nums and then pop, and if you do this now, by now 4 has been removed. So let's see nums. As you can see, yeah. How about if I just mentioned some value pop, and if I say 2, and let's see now. Oh yeah, no, it should be 2. Zero, yeah. So index, sorry, this is the index, not the item itself, but the index. So we just wanted to pop out 3, as you can see. So you can also pass the index, but if you don't pass the index, it just removes the last item. Okay, that's how it works. And now let us see, actually insert pop, no, nums dot insert. And then you have to have, where do you want to insert? If I want to insert it here, for instance, I have to say 0, and then the value is going to be maybe 100. Okay, so I'm expecting 100 between 1 and 2. Oh, actually it's before this one. So it just take, yeah, so it means actually it's taking the place of the 0 index. Yeah. If you want to put between 2 and 3, which should be 0, 1, so it should be 1 actually. In that case, we will. No, it should be 0, 1, 2. Let's try this. Yeah, it's, as you can see, 1, 2, and in between that we have this. So we want to see the 100 at the 2 index, 0, 1, 2. So we just managed to insert that value. Yeah. Then how about if we want to actually append many items? This is how we do actually, nums, and then extend, you can say 4, 6, 7, 8, 9, 10. So this allows us to just append quite a lot of items at once. As you can see, we managed to. Yeah, these are the common. So this, did we see append? Append, just one item, and then pop to remove one item from the end if it doesn't have index. Extend to append many items, and insert to insert items anywhere in the list. Yeah, these are the very commons. Now I will show you what, for instance, if I have num1, I think nums1, it could be 1, 2, 3, and nums2, and if I have 4, 5, 6, what would be the result of nums1 plus nums2? I think okay, what do you expect? Yeah, actually it's a concatenation, yeah? This is just concatenate. So after it's concatenation, so you don't have to worry about this, and it's good. But there is sometimes, like if you have countries, and if you have Finland, and if you have Sweden, and if you have Norway, and if you have capital cities, and maybe you have in Helsinki here, and I don't know, Stockholm, and then Oslo. Now, as you can see, we need to actually zip this together. Really, what zip means? Okay, I will show you. We can zip, and then countries and cities together. So it create list of list and print. Let's see what's the value there. You don't see, as you can see, it's not easy to see. It's an object, so we have to change it to a list. Yeah, now as you can see, this created a tuple. So Finland and Helsinki together, Sweden and Stockholm, Norway and Oslo. Yeah, so it's so great. It's so easy to loop through. But if you are looping, you don't have to change it to, so you can say for, you may say country, or just you just say for item for the time being. And now let's just print one of the item in the list, and you may have a chance. I think we need another more of the zip. And even if we don't need the external zip, I think it seems just nothing there. Yeah, have you seen this one? So yeah, and even we can structure it from here. The first one is going to be country, and this the city, right? So now city, country, and then city. We see, yeah. So it's great. So we have seen zip, and the other is enumerate. Enumerate. For instance, let me show you this. Yeah, countries. How about if I say enumerate, and then if I say countries, it's hard to know the index of this, right? But this actually gives you an index. So print and let's see. Again, it's an object actually, so it's hard, an enumerate object, it's hard to see. Again, we have to change it to the list and it will be so easy. Yeah, now again, Finland is at the first index and Sweden at the, Finland at the 0 index, Sweden to the first and Norway to the second. Actually, we can also use this enumerate whenever we look through. You may say for I, and then, but this I actually no, instead we have to say item, and then now we can print the item. I think I forgot in. So now if you see, yeah, 0 and the country. So this item actually got 2 values. The first is the index and the second is actually the country. Now let's do the unpacking. If you remember, I is the index and the second item is actually the country. So yeah, then I can say the index and the country. So let's see. Yeah, it's so beautiful. Sometimes you may need to start by adding 1 and it looks very good because, you know, let's just, oh no, I think just F and then F. I'm now thinking in JavaScript. Oh, what's happening here? Okay, now let's just inject this value and just to make it look like just an English text. So we can do something like this. As you can see, Finland, and then, yeah, Finland, Sweden, Norway. So we made use of this, the index to do some formatting. Yeah, it's powerful, right? So I think we have finished also the list part. And then what's next actually? Tuples. Yeah, tuples. Tuples, set, and dictionary. But it will take too much time to go step by step for every data types. But what's the difference between tuples and list? They share quite a lot of similarity. The difference is actually we can't modify tuples. Tuple is immutable. Yeah, we can access it by index and we can loop through, but we can't modify it. Once if you create it, it's created. And then what is set? Set, it's not an order, but tuple and the list are order. Set is not an order. For instance, if you say for a new set, country set, maybe num, and set of in a range, maybe just let's me create 10. So actually I'm creating now here yeah, so this is what a set looks like, and there is no order, okay? But we can loop through, we can add, and we can remove, and I think it's better if you look at it from the 30 days of Python. But the difference between tuples and list, this doesn't allow also duplicate, okay? For instance, let me show you. If I put 1, 2, 3, 4, 4, and 2, 1, and 3. So set will not allow all these duplicates. So you will have at the end 1, 2, 3, and 4. So let's see the result again. 1, 2, 3, and 4. Yeah, it removes all the duplicates. So the most use cases of set is actually to remove duplicates of products or people names or country names whatsoever. If you have a plan to do that, then I think set's very good. And tuple, whenever you don't have a plan to mutate or modify your data, then I think tuples is good. Dictionary, whenever you have, for instance, dictionary, let's create a dictionary of something, yeah? Finnish to English dictionary, yes, let's do that. Finnish to English, that's good enough. So we need the curly bracket, and then we may have a word here. For instance, then sana could be word in Finnish, and maybe another word, maybe a house could be a talo. So easy words, and then a house, yeah, and then maybe what else can we have? Who maybe, and then to speak, or yeah. So we have now a kind of a map, a key value. Yeah, great. So the reason why we call it dictionary, it's not only meant to just create such a kind of a language to language dictionary. Actually, it's very useful to develop application, yeah. So from Finn to now, if we want to know what is word in, I mean, what is Finn to English dictionary, we go and then check what is sana, right? And then we should get a word, right? Actually, it's a word, great. And then print again Finn to English, and then if we say, hey, what's talo in English, and then talo in English is house. Okay, then print what is the thing to English, and then if we say poo-hoo, and then we may get to speak. Oh yeah, great. But it would be more than that. For instance, a person's information, person, and there might be a person's first name, and for instance, my name, as you can see, and then last name, and then it could be my last name or your last name, I think, and then the country, and the country. We wrote this example 100 times. So I think this should be now like hammered in the brain, and you will remember forever. Age and 250, and skills. Yeah, okay, let's do that. HTML, CSS. As you can see, it says skills because we have the intention to add list. Yeah, so you can say JS. And now let's start, is married, is this person married? Let's check. And yeah, true, yes, true. What else? Oh, maybe we are interested to know the address of this person. As you can see, even we can write another dictionary. Okay, then address a city, maybe Helsinki, or then street address, a street name, and yes, space street, and zip code, and zip code, you can give 0200 whatsoever. Who cares about this number? No one, but I think it doesn't like that format. Yeah, so as you can see, this is a proper dictionary. Can we look through? Yes, actually, 4 items in the dictionary, and then you can say print item. Then what you get actually is the key. All the keys. What's wrong? Skills is not defined. Skills. What's wrong? Oh, guys, I'm thinking in JavaScript. Everything should be like this. Everything, okay? No one said anything. Let me see. Oh, no one said. Okay, guys, are you with me? We will have a break soon, okay? This is going to be yeah. So some things are so similar with other languages. So in that case, it's very common to make such kind of a mistake. Yeah. Oh yeah. So let's now try again, and by now it should work. Yeah, as you can see, I just got only the key. So if you are interested in the value, what you should do, you can just say, hey, person, and then I'm interested in the value. So this is how you get the value out, because now, as you can see, I just got the value for Sabina, and then as you can see, family name, the country, the age, the skills, and is married, and the address. Yeah, great. Now let's have a 15 minutes break and we will come back. Yeah, see you soon, guys. Welcome back. So we've been talking about dictionary, a very important data structure. I just love dictionary. I hope you do the same. And we just looked through this, but can we modify once if we create a dictionary? Do you see this person's age doesn't sound really correct? Yeah, can you believe someone can live 250 years? That's too much. So let's try to modify person age. Maybe I think if this person can make it up to 150, that's good enough, right? So then I think the other is okay. Maybe this person also doesn't have any nationality. We can also actually create a new key and value. We can say person and the nationality, and then we can say, let's just print this out, print a person, and then by now our dictionary should be with the updated data, right? Let's see. As you can, sometimes I don't like this. Yeah, do you remember the p print? We can use p print and it's so nice. From a p print, import p print. And I think by now you are very good at how to import modules, right? So let's print this again. And now, as you can see, it's so pretty. Yep. As you can see, the address of this person and the age is 150. It's not anymore 250. And the nationality, the new key value is also here. And sometimes we can also use different methods. For instance, we can say this person dot keys. If you do this, actually, we get all the keys of the person of dictionary. If you are interested in the values, person dot values. Yeah, so let's print this. All the keys of the, what do you mean by all the keys? The first name, last name, country, age, skills, is married, and the address. And then I think the print doesn't look right, print, and if I just say print values, and then I will just get the values. And let's see by printing. Yeah, as you can see, these are the keys, and these are the values. I think even now we can use, if you have an object or if you have a dictionary or this, yeah, a dictionary or a list, you can use the pprint. Already, preprint is not defined. I thought we did per, why? How did I remove it? I thought I had it already. I think I have removed it somewhere. From pprint, import pprint. I don't know how I removed it, but anyway, let's print it again. I didn't really modify it that much. Anyway, it's like this. Okay, what else? One of the other is also person dot items. We can change it to items. If you see this, let me show you. Maybe we can also store it as in items. Items, and then you can just put it like that. So we will have a tuple that have keys and values. Yeah, as you can see, key and value. And it's also easy to loop through for item in items, and then you can print one of the item and you will have a tuple, by the way. Have you seen a tuple everywhere? So then I can actually say like this, if I am interested, underscore, and then the value, and then if I will talk about that underscore. As you can see now, I just got more underscore means I don't care about the key, but you can just call it key. And if you don't want to use the key, just go for the value. But if you are not going to use this value, just go underscore. Yeah. Not to confuse you, let's say call it key, and you don't have to use the key later. Yeah. One of the value, one of the method I would love to show you is actually this get. For instance, I can say person, and then if I say phone number, then what do you expect? We didn't have a key value phone, right? Yeah, you can see there's no phone. Actually, now it raised an error. Yeah, there is no key error, right? The key error. But if I use actually this value, the get, and then phone, it will be okay. It will be none. Now none, as you can see. Now, just to be sure if it's working, you can just nationality, for instance, nationality, and it should give me the nationality because it has a nationality. Great. I think this is all what you need about a dictionary in Python. Yep. Now let's move on to maybe I think we are just working on one. I think I call this the basics of Python revision. Great. And then now let's move on to loops. How about loops.py? I think everybody knows loop, why you need. Most of the time, you know, the things we do are very repetitive. So we need a loop. For instance, if I ask you to send 100 messages to people, the same message, or if I ask you to print hello world 1,000 times, hello world, just hello world, 1,000 times, it will be very boring. But if you know how to do that in a for loop, it would be so easy. So you need for I in range, maybe let's make it to 10 times, you know, and you need this the colon, and we have to indent this. Now this allows us to print actually how many times? 10 times, as you can see. So this one actually starts from 0, if you want to see, from 0 to 10. Yeah, but you know, instead, let's see what's happening here. first, I told you where we learned about the range. The range allow us to create a list. So this from 0 to 9, right? So, hey, for I in range whatsoever, for instance, up to 5, print the integer. Yeah, so that means one of the item, as you can see. And then we can also multiply the items while we are actually printing if we want. And oh, you guys are very familiar with this string interpolation. And even you can do I times, again, I is equal to some kind of just fancy output, if you. And let's close it. Why is this F? Oh, I see. I see. That's strange, right? And let's close it here. And now you may see something pretty, right? 0 by 0, 1, 1 by 1. Yeah, do we have to, if you want, for instance, maybe you can start from 10 to 100, right? And if you want to just print out only the even numbers, you can do this, right? Yeah, as you can see. And then I'm like starting from 10 by 10, 12 by 12, 14 by 14, and but what's the need to do that? We can just do something like this. This is from 0 to 99, but if you put this from 0 to 1, yeah, this is a piece of cake for Python. So let's run it. Yeah, as you can see, yeah. So this is a for loop. Can we do the same with a while loop? Yeah, why not? So let's comment this out. Why? I told Control Shift. Yeah, let's do this with while, but we have to start from I is equal to 0, while I is less than or equal to 100 or 101, something like this, and then we can print I think I can just take this value here. And every time we have to increment I plus I, right? There should be an increment. Yeah, this is the code we need. Yeah, but because it's quite a lot already. What am I doing here? It seems that it's not incrementing because why? I think we are end up with infinite loop. Yeah, have you seen? If you see something like this, that means it's an infinite loop. So you have to stop it, like Control Shift C. So we have to read our code again, yeah? So our starting point is actually 0. Great, that's our initialization. And while I is less than 101, so we have to do the increment, but why it's not incrementing? So it should be, yeah, by 1. It should be 1. The increment should be 1, not I itself, okay? That's the mistake we made. And another way, shorter way of writing this also, you just write something like this, but it should be 1, okay? Now let's write it again, and you get something like this, the same result. And this is loop. So initialization, condition, and increment. But in the case of for loop, actually we are iterating the list. This gives you a kind of a list, yeah? And if you have also a list of countries for I, or maybe for C in range of maybe, I think we have these countries all the time. Where do we have the countries list somewhere? Yeah, we can take it here, and maybe I can put it here for countries and then you can just print C. Yeah, and at the same time, maybe if I'm interested to change it to uppercase, or maybe even if I am interested to slice uppercase, and then maybe if I am interested to slice the first three letter, let's see. As you can see, yeah, but it doesn't, since it doesn't include the last, I have to put it to, yeah, Finland, Finn, something like that. And if you want to create a list of lists, something like this, oh yeah, then even if we are interested in the length of the country, the length means the number of characters. Yeah, so maybe if you want to create a new list of country, maybe just new list, I can just create something like this. And instead of printing them out, actually, I can say new list and then append this value. Then by the end, if you just print the new list we created, it would be something like this, right? And now this might be actually take us to list comprehension, right? Yeah, so you guys like list comprehension, right? So list comprehension.py. Yeah, so let's say nums and you have 1, 2, 3, 4. And if I ask you, hey guys, I want you to create double of these numbers. That means 1 should be 2 and 2 should be 4 and 3, 6 and 4 going to be 8. If I ask you, I want you to create or map this to the something like this. Of course, there is a different way of doing that. For instance, you may say a new nums and you can just create a new variable like that. And then you should loop through num, one of the num in nums or the items. And then actually new nums append every time by multiplying 2. Yeah, then the code you need to achieve that. And then print new nums. And if you see now, as you go, yeah, we got it, right? This is what we need. But I think list comprehension is much even better. We can say for num in the nums, and then we can just write the num here by after like this. And it's a very efficient way. Let's see if we get the same thing. Oh yeah, we got the same thing. So this is how list comprehension work. And actually we can also try to do this the country. Let's just have the country here. And if I say for country in countries, yeah, for in countries, and then we can say, okay, C to upper, and then maybe C to upper, and also we want to slice it up to the third character, and then maybe also want to know the length of every country, C. And then actually if you print this out, it's a new list of lists. Maybe I can just list of list. Now, you can call it whatever, but for now, just to declare it as in some value. Oh yeah, oh yeah. Have you seen this? Yeah. This is actually list comprehension. List comprehension is very important. Sometimes we can use it like, where is this? Sometimes it allows us to map, to filter, something like that. So it's not just mapping only, it allows us also to filter actually. Now, maybe I can create a kind of whole number. This is a whole number, right? Whole number is in mathematics that have 0, 1, 2, 3, maybe I think instead of whole number, let me call it integers. Yeah. So integers could be minus 10, minus 9, minus 8. But instead of, have you seen how boring it is creating like this? Yeah. So tell me, I can use actually range starting from minus 10, and I want to end at 10. And yeah, this is how I want actually. So if you see, and I call this integers and print integers, let's see. Yeah, but unless you put it like this, list, and now let's see. Yeah, have you seen now? It's a very beautiful integers, like from minus 10 to, yeah, from minus. So in this side, if you want it to be, so it should be 11 because this, it doesn't include this, the end part. Yes, from minus to 10. Now I can use actually list comprehension only to filter the positive integers. Positive integers. Oh yeah, list is, I mean, list comprehension is so powerful. Then go to the integers for I in integers, and then I can say I, and then we have to have if condition here. If I is greater than 0. But why is it? Robert? Yeah, I forgot. In. Right. Now let's see parse print positive integers. Oh yeah, as you can see, all the positive integers. Is 0 a positive? No. 0 is not a positive, 0 by itself. Of course, if you want, you can say including 0, but as you can see, 0. Oh yeah, but let's just, only the positive integers. And if you want to also get the negative integers, you can just copy this and do the other way. I can write this negative, and then this should be less than 0. And then this is also going to be negative. So now we are using list comprehension for filtering. As you can see, from minus 10 to minus 1 is actually the negative values. Okay, maybe even numbers. If we say, how about even we can do more positive even numbers? Yeah, positive even numbers. Yeah. Then we can say for I in integer, as you can see, if I is greater than 0 and I is actually divisible by 2, and this is actually an even positive number. And now let's print positive even number, positive even integer. Positive even numbers. Yeah, it is okay. Positive even integer, but maybe just to align with this one. But even integer. Numbers also okay. Integers. Let's see. Yeah, as you can see, 2, 4, 6, 8, and 10 are positive even integers in the list. So we can use this list comprehension to filter data out. Now we saw loops, list comprehension, and it seems it's a very good time to start function. The functions are so powerful. And the reason why we use function to make our code reusable. Yes, maintainable, yes, and testable. It's so easy to test, testable. Yes, great. Now, for instance, def followed by name of a yes, a function, and followed by a parenthesis, and then we can do whatever we want. And for instance, print I am a function here. So how do we make use of this function? If I run this file, I can run nothing, as you can see. Yep, so we have to call the function by its name. So the name is actually name of a function, and I have to invoke it. The parentheses also be closed like this. No, I am a function, but instead of printing, we have to return something. As I told you, now I'm returning a string. Guys, this is very important. You should know what you are printing from your function. As I told you at the very beginning today, programming is all about data types. We store data types. We return data types from a function. Now, as you can see, I am returning. If I just click over here, you don't see anything because we are not printing this out. Now let's printing that, and then you see I am a function, and actually the type of data you are printing out is now a string. Can we return number? Yeah, why not? For instance, let's print this out. Yes, we are printing number. Returning. How about Boolean? True. Yes. As you can see, it's a true value, or maybe the value could be 2, yes, greater than 0. And yes, that's true. Can we return something a tuple? By the way, if you say something like this, 10, 20, and 30, if you return something like this with a comma separation, I think the value you get is going to be a tuple. By nature, it will be a tuple. Let's see. Oh, have you seen that? Oh, yeah. So if you return something like that, it's a tuple, but you can also just put it like this. It's a tuple again. Okay, great. Can we return a list? Yes, we can return a list. For instance, 9.81. I love this number, 3.14. I love this number, 2.7, and 100, the boiling point of water. So let's see this as in a list. Yeah, some list. And then how about a dictionary? A dictionary could be a name, and the name is going to be John Doe. John Doe. Oh yeah, so as you can see, you may say as in dictionary. Yep. How about if you don't return anything like that? Then let's just say pass. And how does it? Oh yeah, none. Yes, this is something I want you to really focus or maybe remember. Yeah, if you don't return anything from a Python function, it's not every programming function, but only in Python, it's none. Okay, if it's in JavaScript, it's undefined. Oh yeah, great. So now let's change this to make square function, and it should take some parameter. Oh, parameter is like a placeholder. Okay, now I can just return n by n, or maybe just a fancy way of writing a square of something or a square of a number is like that. So I have to call it by name. Yeah, if I call you by name, you should say yes, right? And the same goes for this function. And if I just say, I should get 9, right? Oh yeah, it's 9. And of course, you can test it a couple of times. What's -3? And for -3 also, I'm expecting 9. And if it's maybe 10, I'm expecting 100. Oh yeah, great. Now we have created this function. How about def double number, double a number, or double number? Okay, so if you have n, this instead, it just multiply your number by 2. Yeah, And then if you have another for multiply, or maybe add two numbers. Add two numbers is a function that AB, then it returns A plus B. Yeah, so clean functions. Now we don't make use of this. Maybe we can use this in another function, in another file, right? So I have, how many functions do you see here, guys? I have a very silly question over here. How many functions do you see here? Okay, great. What's the data type this function is returning? Yes, great. It is int. Yeah, great. Now, for instance, if we have def calculate weight, calc weight, and we may have this the mass and the gravity, and then actually we can return mass times gravity. So what do you think the value, what data type this the calc weight function is returning? Most probably a float, right? Yeah, so this is how you return a function. And now I want to add nums. This add nums actually going to add unlimited number of parameters, okay? But I want to show you how this works. Now just maybe console.log and just nothing. And let me just call this function add, console.log, no, sorry guys. Print, just now I have this numbers, and if I just put 1 and 2, 4, 5, whatever, I want to add all these numbers together, and there's no any way I can just have, if I just want, if I say BC, but you know, the user later may have quite many arguments here. How do I access that? There is this 1 star and followed by args. It's like argument, but this name could be any name. And let's see this, the args, what it provides me is actually a tuple. Nice. How about if I just make this also 10, and maybe 25, and maybe 30. And now let's see again. My tuple is increasing now and then. So I think if you have a tuple, you can say a total, and let's say 0, 4. I in args, then what you should do, total, and you can say plus the I now, and then we don't need this, and we can return the total, right? Oh yeah, now I think we have to print this out. Print total. No total actually, add numbers. But I think I have already that in the clipboard. Let's see the value. Oh yeah, we got, yeah, this. By the way, we can also use this, do you remember map, reduce, and filter? Now we are talking about functional programming again. So we can say from func tools, from functions import, I think no, it's from func tools, import reduce, and reduce allow us to make this code a bit shorter. You can say, hey, reduce and take the list darks. So maybe I think first the lambda function, hey lambda, x and y, just add x plus y, and then we have to throw the args, and then we don't need all this value. This will be actually the total, and by now you should be familiar with this return total. And now our function should again work. Oh yeah, 80, great. if you just also maybe minus 80. Now, since this was 80, it's so easy to know the total. Tell me the total now. Who is there? This just to check if you are following or not. Okay. So if the I'm expecting 0 because I just added mine. Oh, yes. Okay. If I just put minus 30, so I'm expecting 50. Great. Yeah. But even you don't have to do this, and you don't have to store it, and you can just return this. Yeah, return, and that's good enough. Now we don't have to do this also. Now let's even do more functions. How about if we have reverse an array? So this or reverse a list. Okay, this takes a list and it should reverse it. How do we do that? And then it should take a list. Yeah. But there's already this function that reverses a list. But maybe if we want, maybe I think I can show you a different way. If you have nums, and if you have this 2, 1, 2, 3, 4, last time, if you remember, you managed to reverse this, and then if you do this, actually you will get a reverse of this number, and that's also okay. Yeah. That's also okay, but you can also do it in different way. And how about if I ask you, it's just a function that check if all the elements are actually string. Yeah. Check data types, and then it should check list and then the type. And now this one, for instance, I may check for list, for item in list. You have to count, maybe I can just count 0, starting from 0. I can say if if item, if type of the item is equal to type, and then actually count, I'm counting by 1 again. Okay, then what I should do, I compare total number, length, if count equal to the length of list, then I return true. Else, or just return false. I will explain this to you guys. What is this? Tell me why this not. Oh, I'm using this too much. Okay, now check data type. Let me show you. Nums 1, 2, 3, 4. What's the data type of all the items here? Are they the same? Oh, guys, tell me. What is the data type? Yes. Are they the same? Yes. And what type? Yes. Int. Now I can say print check data type, and then I have to nums, and then if I say int, now let's see, I am expecting actually true. Stir object is not callable. Okay, I think my function got something wrong. Let's check line 27. Because as you can see, this type is even not a very good, because it's already a kind of also predefined, maybe I can call it T, but it's going to represent the type. It's confusing, okay? Oh yeah, false. Why is it false? For some reason, it shouldn't be false. It should be true because all the data are int and we are expecting int, but so we have to figure out. So how I did count for item in list, if type item is equal to this, yeah, int, maybe oh yeah, it's true now. As you can see, it doesn't need this adding. How about if we just change this to string, and now maybe we can have these values, for instance, names, and if I just change this to John, and if I just change this to Bill, and if I just change this to Steve, and it will be done. And this also names. Yeah, it's working. How about if I add additional value here, 9.81? So this should be false now, right? Oh yeah, great, because all of them are not. So we wrote actually a function that check a data type of a list. Yeah. Okay, very good. I think now we spend good enough amount of time writing function, and maybe something you should be aware of. For instance, if you want to give a default value 9.81, so sometimes you don't have to pass a value for this. Yeah. Now let's learn at the same time also importing module, importing modules.py. So we can say we have already available modules. If you remember, I can say import p print. Yeah. So I'm now importing everything what the p print has. And then if you say print other p print, and then you will see quite a lot of modules over there. Yeah, but you and I, most of the time we were using the p print, right? So if I am interested in the p print only, I can say, hey, go to, that means from p print, import p print. Yeah, one of them. And even if I don't like this, from p print, import p print as p. Don't do that. After this, I can use p, by the way. For instance, p, and then I can say, for instance, let's print one of our objects somewhere. I think, was it in here? Yeah, so this is a very good object. So let's take it somewhere. And printing using this, the p, right? And then person. Yeah, you're so familiar with print. Now we are just using p because we imported it as p. Yeah, as you can see, the p works. So we can actually print it as in like from p print import p print, as in like that, or as in something else, as in p, or whatever, or pretty print, whatever, pretty print. Yeah, This is good, right? Pretty good. So now you are sure that you are about to print it in a pretty or prettified way. Okay, yeah, still it works. Now let's do more. I can just comment this out and let's use this, the mat, because import the mat module does quite a lot of methods. Then import dir match. So what do you mean by this? Actually, you are about to see the available methods there. Let's see. Oh yeah, this different. All the mathematical methods related to trigonometry, a logarithmic function, factorial, whatsoever you want. It's not actually very exhaustive, but most of the common. So how do we import these guys? Okay. For instance, it's so easy to do 2 times 2 times, I mean, this is square, right? 4, it gives you, but what's the square root of 2? Maybe it's easy. The square root of 9 is 3. The square root of 4 is 2, but the square root of 2 is actually 1.4. It's so hard to calculate. So let's import that. Print mat dot square root, and then I can say 9, yeah, and then import print mat dot square root, and if I say 2, yeah, I think we are expecting from this line 3, and from this 1.4 something, right? Yeah. Oh, it's great. Maybe sometimes we can use also, for instance, if you want to do the square root of something, you can use 0.5. So 2 the power of 0.5 should give the same result, as you can see. Or maybe you can see print 2 the power of 9 the power of 9 the power of 0.5 should give the same, that's 3. Yeah, as you can see, it's giving me the same result. Okay, great. Now, instead of mat.square is maybe a bit boring, so you may import something like this. From mat, import square root. Yeah, this is good. And now we can remove this. Yeah. And then actually we can import at the same time mat import. Now, as you can see, I don't know what to import. At some point, for instance, we have ceiling, maybe the ceiling and the floor, and maybe a factorial if you want, power, and another maybe a log if you want, the logarithm of 10 or the logarithm of 2. And let's see, and logarithm of 2. What? Yeah, this is good enough. And let's check them. Okay, then print a ceiling of 9.81. What's the ceiling of 9.81, guys? That ceiling means actually rounding to upper, right? Rounding up. So when you round up this, it's going to be 10. And yes, you can also use print floor of 9.81. So if you round down this, so it's going to be 9, right? Oh yeah, but when it comes to ceiling, print a ceil. For instance, if you do a ceiling of 3.14, it's not fair. This 3.14 will be rounded to 4, right? It's unfair. Yeah, it's so unfair. And also this 9.8 is going to be rounded to 9, and that's not also fair. Okay, let's go. Power is also another alternative. Print, you can say the power of 2, the power of 2, and it's 4. Yes, you can see, but a very interesting one, print the power of 2 to 10, I'm expecting 1024. Yeah, great. How about the logarithm of? Yeah, print the logarithm of 10. I mean, the logarithm of maybe like 10 to the base 10. I'm expecting 1. Is that 1? Or yeah, it's 1. Yeah, that's how about print the logarithm of 10 to the base, I mean 100 to the base 10, and it's going to be 2. It's logarithm, okay? And if it's 1000, it's going to be 3. So it works for also. Now what we are learning actually is importing one by one, but you can do actually, you can import everything like this. From math, import this, everything. This is also, you can do the same, and now we should get everything. Yeah, have you seen? Now this means importing everything. Of course, you can just do math, import math, and of course you have to attach to math dot and math dot to every method, but that's not very fancy way to do, and this is not also good importing everything, so I would recommend importing one by one. Okay, now you know how to import available module, but how about actually importing our own custom module? Importing custom module. Let me just call it, okay, fine, just give it a try. So import, what is the module we created? Actually functions. So instead of functions, I can call them actually some names. I can call them modules. Okay. So I can say modules. Great. Then if I say print dir modules, yeah, it's really good, this dir, guys. And then you will have a chance to see everything. Are you familiar with this? Add numbers, add two numbers, calculate weight, check data types, double number, make square. And now we can import this, guys, and then import, no, I think it's already imported, but I think we can say modules dot add numbers. Add numbers actually takes 3, 4, 5, 6, 1, 2, 200, whatever, and it should do some calculation, right? Why it's not running? Yeah, it gave me this. And you can also import the others, but we can say instead from modules import add numbers, make square, calculate weight. What's the other? Add two numbers, whatever you can. So now we don't have to do this. And now maybe let's do, for instance, there was this check something data type. For instance, if I say print, check data types, and if I just give it 1, 2, 3, and if I say these are stars, it should be false. Now let's check. That's false, but if I just told it's int, all are int. If I change one of this to a string, and it should be false. Great. Now you know how to import already available core modules like the math module, and also you know how to import custom module. It's not different from the core modules. Okay. Yeah, so what shall we learn additional thing? I think the list, the higher order function is very important to learn. Let's just make that a bit. So higher order function.py, as I told you, higher order function means you have def, make square, right? And then this is a very simple function. It just take one parameter and it just return the square. But how about if we just have a cube? Hey, make cube, and this make cube also takes one parameter, and it returns in this. But actually we can rewrite this differently. Instead, how about making the square first? Then we can have this callback, a function, hey, func, and then we have this number, so we can rewrite it differently, func, and then n times n. This is actually, so we are about, this is a callback function. This is a higher order function. The definition of higher order function, a function that take another function as in a parameter. So let's make use of this. Print make cube, and then this function is a placeholder for actually make square. Then I can call it, hey, make square. Go there and do something. And let's see 2. So the cube of 2, I'm expecting 8, and I hope you do the same. 8. Oh yeah. So the cube of now, let's see, for 3, it's 27, and for 10, it's going to be 100. And let's see. Actually, for 10, it's not 100 because 10 by 10, 100 by 10, it's 1,000. Oh, yeah, great. So this is a higher order function. Another higher order function could be, for instance, a function that return another function. Okay, def add 10, or do add, maybe do something. This do something function, it takes a number, and now I am just returning another function, def add 10. And so as you can see, return n plus 10. So, and this function is returning the add 10. So as you can see, this function was not yet called. So if I make use of this function, print do something, and if I do this 5, you may see just a function itself. Because, yeah, it's just a function because it's not yet called. So I have to invoke it. I have to invoke it like this. Now I should get 15. Oh yeah. How about if it's 10? Then I should get 20. Yeah, so this is a higher order function. So the value we pass in here, we call it callback, but in this case, actually, we just return the function. Even we don't have to even return it like this. We can even no, don't do that. I can return it like this even. Why? Okay, let's keep it like that. Yeah, the previous is more cleaner. Okay, good. So why we need to learn this? Because, guys, we have learned the functional programming. So now let's go to the functional programming. Yeah. So what is that? The functional programming, if you remember, the map, the filter, and the reduce. And these guys usually need some callback. So if you remember, you have nums. Of course, you can modify this value 1, 2, 3, 4. And if I ask you to make a change in this to double or square like this, 1, maybe let's go for a double, 2, and then 4, 6, and 8, right? So you can go for list comprehension. But maybe now if I ask you to do it in using a map, so what we should do, we can say double, first def double num, and we have to have n, and then we should say return n times 2, right? Then I will use this function map. Hey map, go use this callback function, and it's going to be, the name is double name, and iterate through the nums. Yeah? And then let's see the value here. Of course, you will see an object, but you know, that's an object. Great. At least we have an object over here. So we have to change it to a list. And if you see the list, it will be actually, yeah, 2, 4, 6, 8. Great. Oh, yeah. Maybe if we want to make square, it could be also changed to make a square. And of course, you have to change this to also make square, and the way it works should be also changed to make square, and instead this is going to be 1, and it's 4 and 9, and it's going to be 16, right? Yes, let's try it again. Why it's not running? Yeah, 1, 4, 9, 16. Great. Now this is a higher order function that takes another function as in a parameter. So it's actually the same as here as I showed you. Make cube is taken in a function as in a parameter, and there's also another parameter. This value goes in here, and then it will be multiplied. So when we make use of this, actually, hey, make cube, how about if you use the make square function, and then inside the make square function, use this 2 to change it to square, and then multiplied it by the number. Yeah, that's actually a cube. Okay. Oh, now where are we? So as you can see, we made this. How about if we need? But I think when it comes to this functional programming, we don't need to declare a function like this, because we have this lambda function. Lambda is so powerful. Because, for instance, if you have x, you can change this x to the x square, right? This means x square. Or you can double it if you want. Or you can have a x, y, z, and you can sum all of them together or divide them together, whatever you want. Yeah. So this is pretty. This is so pretty. Why? X, z, z. Okay. This is everything. Then instead now I can change. Hey, lambda, take care of num, and the num should be this. Okay. No need of doubling here and having additional function over here. So even now we can store this separately, and it will looks like I can say nums squared. Let's print nums squared. Oh yeah, 1, 4, 9, 16, right? That's nice. And now let's move on to filter. Okay, so if we go for filter, now I think I am in favor of this countries. You know, I think you love those countries list also. Let's start from Finland, and and Sweden, and then Norway, and then okay, and Iceland, and that's all we need. Okay, now you know there are some countries with land, and let's filter that. Okay, so what you should do, filter, and then lambda, and one of the countries C, then see that, or maybe actually you say land in C, So this is good enough. This, and then we have to have the countries. And then we have to change this to actually a list. Countries. It should be written like this. Countries is land, and we can store it like this. And sorry for this. What? I can just modify everything at once. Countries. Okay, so by now, and this should be also actually should be changed to a list like this, because if not, it will be a map. I mean, an object. Sorry, countries with land. Oh yeah, as you can see, Finland and Iceland. Now let's just use the reduce also to sum this together. You can use, first you have to import from functools, import reduce. And you may say, hey, reduce lambda x and y, and just add all the items together from the nums. And then if we sum all this together, we get 1 and 2, 3, 3 and 3, 6, and 10 every, yeah, so you can keep it as in a total. Total is like this. So short code, right? So print total. Let's see. Yeah, as you can see, it's 10. Great. Do you have any question, guys? Since the revision is fast, okay, it's fast, I see. Let me see other topics that might be important. Okay, now let's fetch data from the countries API, and not the countries actually. Let me go to the advanced Python September group. Maybe I can just look for here the cats API. Documentation, and if we go here, I think this. Oh yeah, so I can record this separately maybe, and it will have 2 parts.